Now it's time for Cudjoe, and he's going to talk about differences in biomass models between monospecific and mixed species forests.
Thank you. Yeah. Good afternoon, everyone. I don't know, but after eating, I'm feeling shy. Okay, so I'm going to talk about differences in tree biomass allocation between monospecific and mixed forests. First of all, my presentation will go with the introduction, my objectives, material and methods, results, conclusions. Today, we all know that the whole world is facing a climate change problem or a global warming, and one of the solutions we turn to is the forest. But ask yourself why we turn to the forest as a solution to global change or climate change. The main reason why we turn to the forest is because the forest can accumulate a large amount of biomass, and also very important in the role of reducing or regulating the greenhouse carbon emission and CO2 balance on the earth. So therefore, what do? It is very necessary for us to be able to quantify the carbon stock in the forest. But quantifying need to be very accurate. Therefore, when we researchers are coming up with models, we need to pay attention with the accuracy of the models, because it's going to help us to have an idea about the amount of carbon in the forest. Recently, there have been several debates about what type of forest is very important, or the benefit of pure forest and mixed forest. So if in Europe specifically, a lot of forest managers are moving from pure forest to mixed forest. But ask yourself why. Several reasons. The first reason is because research says, some researchers or most researchers are saying that it has a higher productivity, and also it has a positive impact onto the climate change in terms of windbreak, the effect of impact of pests and disease. It has higher resistance when we compare the mixed forest to the pure forest. However, there are some researchers who also do say that they do not find the benefits of pure forest to mixed forest. So upon our research, we were able to come up with some hypotheses. And the first hypothesis we came up with is that, are there differences in the total biomass allocation of pure and mixed forest? And the second hypothesis we came up was that there are differences in the component biomass for both monospecific and mixed stands. And the last hypothesis we came up was the biomass allometry equation in mixed forests differ from the pure forest. So upon our literature review, these are the hypotheses we made before starting our research. So to say that why it's very important to come up with this hypothesis, for us to be able to have an idea about what we're going to have at the end of the day. So for those who don't know, my work is basically on the pure, that is Quercus sylvestris and, Pinus sylvestris and Quercus petrea. So upon my presentation, I'll just sum it and make it just pine and oak for nomenclature reasons, not to be repeating the word. So I'll just use pine and oak. So my research is basically on that. For those who do not know, the mixed, and my work is typically on a triplet. So it's literally mixed forest is both the pine and the oak mixed together, and the pure oak separated and the mixed oak separated, for those who do not have an idea about the mixed forest. Okay, so it's very important for the mixed forest to have an idea about the stand structure and also the total biomass for the whole above ground biomass, and also the biomass of the component. When we say the component, it means the branches and the leaves, in order to be able to provide a sustainable forest management, and also a mitigation action towards this climate change. However, we were able to come up with two important questions for our research. And the first question is above ground biomass of mix more than its pure stand? And the second one is tree biomass allometry influenced by a mixture? Literally, we are trying to say that when we have a mixture, do we have a different tree biomass equation or tree biomass allometry, or is the same? Looking at our research work, two main problems that we face in the method to use for our research work is that we have a problem of additivity effect. Literally means that when we sum up all the above ground biomass, that is the stem, the branches, and the leaves, the sum of them is supposed to be equal to the total biomass. So it means that the method that we have to use, we need to be able to fit these equations to have the same, so that the sum of these three variables will be equal to the total. Most of the work being done normally do it individual. So it means that when you sum the three, that's the branch, the stem, and the leaves up, they do not equate to the total biomass. And this is a problem. So it means that our action that we have to take needs to solve this problem. The second problem we have is also models error. It means that models parameters that we estimate, most of the time there is an error with them. So this is what we need to take into account. Our objective, this brought to our idea about the main objective of our work, as I said, is to know whether is there the mixture. Is there an effect on the, or is there an effect of mixture on the tree allometry? So when we have mixture, is there a difference between the tree allometry of pure and mixed or not? That's the main objective of our work. So, but our work will address typically will help us to be able to predict the total biomass, total above ground biomass, and its proportions of biomass in each component. And the proportions I considered so much here is just the branches, the stem, and the leaves. Due to time constraint, I'll try to sum up a little bit and faster. Where my research work was done was in Burgos and Palencia. So the things we considered in my research work, the parameters mostly were measured were the leaves, the branches, and the stem. For the data analysis, in order to address this problem, what we focused mostly on was the biomass analysis, where we had to build equations. But we used two different types, the logarithmic regression and the weighted regression, as we can see there. And the Dirichlet's regression, which is really, recently it has been requested to be used due to its advantages. So looking at some of the results here is we could see the pure pine and the pure oak. We could see that we did a model and we could see the diameter with the total biomass. There were not much differences. I'll try to go a little bit faster. Yeah, we could see there's a little bit difference when it comes to the two, you see branches, two is the thick branches. And yeah, we could see here as well that the thin branches with respect to the DBH, we can see that pine has a little bit of difference with the pure pine and the mixed pine. So yeah. So most importantly, these are the models we find for the total above ground biomass, where literally you just have to understand that the total above ground biomass is the logarithmic of DBH squared times height. And that is for the pine. And for the oak, we could see there is that the DBH plus DBH squared. Just get this into mind. But we use the criteria for the selection of the R square and then the lowest AIC. For the component biomass, this is the Dirichlet's predicted, which is very important. And yeah, so here we could see the proportions of the biomass for the pine and the oak. For the pine, we could see most often the stem has the highest proportion, followed by the thick branches, the thin branches, and the foliage. But for the oak, bear in mind, during the time of harvest, the oak did not have leaves. So we did not include oaks in our calculation. Our findings of this studies was literally, we could find that above allometry models predicting above ground biomass is similar in the pure and the mixed. So literally, we just have to understand that our model that we predicted, what we did was that we found out that for the mixed and the pure, it was the same. There was no difference. So it disputes our hypothesis that we said earlier on that they were different. So our hypothesis said that they were different, but our result shows that there were no difference. So what is new in our research? As we said, Dirichlet's, the main thing is that our Dirichlet regression that we use here is the first time being used in mixed forests. And yeah. So recommendation I'll just quickly say is that we should build, most of the time, this DBH, we build it on adult trees or mature trees, which is my case, but more research should be done on the smaller trees or younger trees. And also we should have to increase the number of sample trees. And thank you very much.